Oh, you're right. This morning we're going to quickly go through the homework, and then we'll start the new topic. So this homework we won't need to spend so much time on because I've looked at a lot of your responses on Firefly, and generally I thought they were very, very good. All right, so I think it's clear from the answers that I saw that you paid a lot of attention when we went through the model answer, and then you used what you learned in the model answer to answer these two questions. A few things that you need to be aware of is that there were quite a few of you who I think were still thinking about the example when you were writing the answers to these a little bit too much, and then you maybe hear this question is about DDT, which is an insecticide, which is a chemical that kills insects on plants. But a lot of your answers maybe mentioned DDT or mentioned insecticide, but then after a while started talking about microplastics because you were going back to the answer in the model response that I'd given you. The only other thing is that plankton, a lot of you referred to, say, the fish ate one plankton. All right, now we don't really refer to plankton as individual organisms, so you would just have to say fish ate plankton, all right, rather than fish ate one plankton. So if you've got in your answer, which a lot of you have, the fish ate one plankton, you just need to change that to the fish ate plankton. That's just not how we refer to plankton. Apart from that, I'll just give you the food chains. So the food chains for the first one is plankton, which is eaten by fish, which are eaten by these fish-eating birds. Okay, and I think most of you, from what I could see, correctly didn't have DDT in the food chain because DDT is not an organism. So DDT is a chemical that we use to kill insects. So what happens is the DDT is absorbed by the plankton. And then when the fish eat the plankton, they also eat the DDT. All right, and the same for mercury. So there shouldn't be any mercury in your food chain. The mercury is absorbed by the plankton. The plankton is eaten by herring, a small type of fish, which can be eaten by a larger type of fish, swordfish. And swordfish can be eaten by humans. But apart from that, I think we all did very well on this idea of, for example, if each herring has got a small amount of mercury inside it, because the swordfish eats many, many, many herring, the swordfish ends up with a large amount of mercury inside it. Okay, so I really liked your answers to that question. Okay, next we're going to move on to section number 4. Okay, which is a section called Pyramids of Number. All right, so you're going to need either your book in front of you or this in front of you if you've got it printed out, and you'll need a pen, and you're going to need to pause it to draw a lot of diagrams. As you can see, there's a lot of spaces, empty spaces on this piece of paper, and we're going to have to put in a lot of diagrams in those empty spaces. So, let's begin. A pyramid of number is a type of bar chart that shows the population of each organism in a food chain. Copy down a sketch of the pyramid of number for the food chain: clover, snail, thrush, sparrowhawk. So, in our lesson last week, just before we start drawing this pyramid number, if you remember last week, when we were talking about bioaccumulation, you'll remember that we had one bear will eat 5 seals, and each seal will eat 30 fish. Okay, so you can imagine that if you were to have, I wrote it down last week, one bear, 5 seals, 150 fish, because each of the 5 seals eats 30 fish, and 5 times 30 is 150. So what you can see is that this is a little bit like a pyramid, where you have one bear at the top, that one bear eats 5 seals, and those 5 seals together eat 150 fish. So this here is like a pyramid of number. Okay, so what we can do is you can imagine if you were to have one sparrowhawk, well, one sparrowhawk might eat, let's say, 3 thrushes. Now each of those 3 thrushes might eat 5 snails. So if one thrush eats 5 snails, 3 thrushes will eat 15 snails. Okay, and if you imagine each snail eats, let's say, 10 leaves of clover, then 15 snails will eat 150 leaves of clover. So what we do is we're going to draw this in a bar chart. So you will need a ruler for this because I want it to be nice and neat. Okay, so you need your axis along the bottom and your axis up the side. Now, we're not going to draw this to scale for now. Although, if we were in school, we would be doing this on graph paper. Okay. However, because we're not in school, we're not doing it on graph paper. Eventually, so for now it's just a sketch, but it still needs to be a neat sketch. So, along the horizontal axis, we are going to have the number of organisms. Oops. Okay, and along the vertical axis, we're going to have the organism, which organism we're talking about. All right, so we can have, first of all, we start at the bottom with our clovers. Now you see there are a lot of clovers. All right, so we're going to draw a nice wide bar for that. Now, like I said, for now we're not doing this according to scale, which means that it doesn't need to be exact. It just needs to look like that. Okay, so we can see now here, this is our clover. Okay, now when we go up to the next organism, the snail, you can see that there's a lot less. Okay, so if that's about 10 centimeters, well, our snail is going to be about 1 centimeter because it's the 10th, isn't it? All right, so let's say we have our next one is about 1 centimeter wide. So it will look like this. Nice and neat. All right, and that's our snail. All right, and then we're going to go to the next one, which is the thrush. Now the thrush is going to be even narrower. All right, even narrower. It's only going to be about 3 millimeters narrow. All right, so I need to be careful, make sure I don't smudge this when it's getting so close. All right, so that's my thrush. And then my final organism is my sparrowhawk, which I've only got one of. So for that, I'm just going to draw a line. Okay. And that is my sparrowhawk. Okay, so that is a pyramid of number. All right, what it does is it shows that in a food chain, how many of each organism there is at each level. So you can see that one sparrowhawk will eat, a few thrushes, and those thrushes together will eat, a few snails, but those snails together will eat loads of clovers. So in order for this one sparrowhawk to survive, you need this much clover to pass up through the food chain. So if we carry on now, down here, you'll probably need to pause it now and make a nice copy, a nice neat copy of that in your book or on the piece of paper. Okay. And once you've done that, we'll carry on. Energy is lost to the surroundings at every stage. That's why the snails need to eat so many clovers. Okay. Usually, animals higher up the food chain are larger. Okay, so a sparrowhawk is larger than a thrush is larger than the snail is larger than clover. Therefore, I remember clover is just a type of grass, or just it's a plant, a green plant similar to grass. Therefore, there will usually be fewer animals at each level of the food chain, like in our example. However, this is not always the case. So you'd expect a food chain to look like this, and our food chain with the bear and the seal and the fish look like that. All right, lots of organisms at the bottom, only one organism at the top. Right. However, it's not always the case. All right? And we can see that in this example. All right? So you can imagine that we might have one tree. Now on that one tree, there might be, loads. Let's say, 500 caterpillars. Okay, and then let's say each blue jay eats 50 caterpillars. All right, which means there's going to be 10 blue jays. So those 10 blue jays can live in one tree because there's enough caterpillars. Now, if we draw out that pyramid of number the same way that we drew out our last one, you'll see that it looks a little bit funny. All right, so remember, we need to label the axes. This is our organism, and this is the number of organisms. Now what happens is, well, at the bottom of the food chain, we've only got one tree. So that means right at the bottom, we've just got a line to represent our tree. Okay, now you'll notice that when I'm drawing these, that I always put it in the middle. All right, that's how we draw pyramids of number. Okay, we don't put them up against the horizontal axis. We always do it in the middle. Okay, next, I've got 500 caterpillars. Now I'm not going to measure out anything exact. All I know is that it's just 500 is lots. So I'm going to make a nice big wide line for that. Like so. Okay. And then I have 10 blue jays. So 10 blue jays is going to be not very wide, because 10 is much, much smaller than 500, but it's probably going to be something like that. Okay. So now you can see here, this is my caterpillars, and these are my blue jays. All right, so even though this is a pyramid of number, now it doesn't look like a pyramid. All right, so I know that's confusing. It would be nice if they all look like this, if they all look like pyramids, but you need to remember that it won't always look like a pyramid. Okay, so what I'd like you to do now is, I've given you another food chain here. Actually, before we move on, so the reason is that this one tree is really, really big. So up here, clover, those little green plants, they're really, really small, so you need to eat lots of them. All right. However, a tree is huge, and one tree can support lots and lots of caterpillars. All right. So your go. You need to now draw me a pyramid of number for grass, horse, flea. Okay. So you need to think about, well, how much grass does a horse need to eat? Is it a lot or a little? And then how many fleas can there be on a horse? All right, so you quickly have a go at that. Okay, so you should have paused the video there. If you haven't paused the video yet, pause it now and have a go. Otherwise, I will now show you what it should look like. Okay, so your graph should be nice and neat. Lots of rulers, all right. Axis should be labelled. Okay, now, one horse needs to eat a lot of grass. Okay, so I'm going to have lots and lots of grass in my pyramid of number. Lots and lots of grass. Okay, now that might all be eaten by just one horse. All right, so just one horse, like that. All right, so all that grass gets eaten by one horse. Now you have to think, well, how many fleas can I get on one horse? Quite a lot, all right? I can probably get quite a lot of fleas on just one horse. So it might look like this. All right, so this looks a little bit weird as well. All right, but it tells us how the food chain works. All right, so we have lots and lots of grass, all eaten by just one horse, but that one horse can feed lots of fleas. All right, excellent. Okay, so moving on. All right. So here is some data about the population of different organisms in a food chain found in a particular ecosystem. Follow the instructions below to draw a pyramid of number for this food chain. Okay, so at this point in class, we would normally now do this on graph paper. Okay, which is why I've got these instructions like an x-axis, which is 6 large squares long, and a y-axis, which is 4 squares long. Right. However, I mean, if at home you've got graph paper, I realise that this is perhaps not likely, but if you do happen to have graph paper like this, then you can follow the instructions using the graph paper. All right. If you haven't got graph paper, don't worry. What I'd like you to do is, for homework, it's very straightforward today. I would just like you to read these instructions, and then, as we've done for these ones, okay, I want you to use these numbers just to sketch one out. All right. There's not really much we can do if there's not access to graph paper. Okay, and once you've done that, that's fine. Okay, so that'll be enough for this week. All right, and I'll see you all next week.